Welcome back with a new lesson 12.1 Angles and Polygons. Our lesson objective is to apply basic definitions and relationships for angles, lines, and geometric figures to solve application problems. Maybe most of us know that an angle is formed by two lines that have a common point. And this common point here is called the vertex. And we want to know how to name an angle. Since an angle has two sides, each side passes through some points. So if we are passing through this point here, A, and this vertex we can call it P, and the other side passes through a point, let us call it C. So this angle, we can call it angle P, or we can call it angle APC. Also, we can call it the angle CPA. So in all ways, you should put the vertex point name in the middle between the 2 points on the sides. The first name, angle B, can be used when this angle is separated or isolated alone. But if you are having another angle which is common with the vertex point P, such as this way, so suppose that we have another side, another angle, which has a side passes through the point D. Now, if we are talking about this angle over here, we can't call it angle B. We should call it angle CPA or APC. And if we are talking about this angle over here, we will say this is angle DPA. Or sometimes we can put numbers inside the angles, so we can say that this is angle 1 and this is angle 2. So this is angle 2 and this is angle 1. We have different types of angles depending on the degree of its measurement. So we can classify angles to a right angle if this angle was equal to 90 degrees. And we call it an obtuse angle if this angle was greater than 90 degrees and less than 180 degrees. But we will call it an acute angle if it was less than 90 degrees. And it is called a straight angle if it is equal to 180 degrees. If we have a situation that two angles, their sum is equal to 90 degrees, we call these two angles complementary angles. So, as an example, the complement of angle A, which is equal to 70 degrees, should be 20 degrees because the sum of them must be 90 degrees, and these two angles are called complementary angles. But if we have two angles that the sum of them is equal to 180 degrees, these angles are called supplementary angles. So if it is given to you that angle A is equal to 70 degrees then the supplement angle of angle A is 110 degrees, so their sum must be equal to 180 degrees. And any two angles which are on a straight line, their sum must be equal to 180 degrees. Now, if we have two intersecting lines, they will intersect in a certain point, and also they will divide the plane into four angles: angle 1, angle 2, angle 3, and angle 4. Each two angles opposite to each other, we call them vertical angles, and they are equal. So angle 2 must be equal to angle 4 because they are vertical angles. The same for angle 1 and angle 3. So angle 1 is also equal to angle 3 because they are also vertical angles. If angle 1 is equal to 80 degrees, then we can say that angle 3 is equal to 80 degrees also, and the reason here because they are vertical angles. But also we can say that angle 2 should be equal to 100 degrees because it is a supplementary angle to angle 1. When two lines are parallel and they are intersected by a transversal line, such as this line here, we will see that we are having now four angles performed: 1, 2, 3, 4, 5, 6, 7, 8. And there is a relationship between these angles. For example, angle 1 should be equal to angle 3, and that is because they are vertical angles, and this we took before. Also, angle 1 is equal to 180 minus angle 4, and that is because they are supplementary angles, and also we took that before. Now we can say that angle 1 is also equal to angle 5 because these two angles are corresponding angles. Since angle 1 in the upper intersection lies on the upper side to the right, also angle 5 is lying on the same position in the lower intersection up to the right. So these are corresponding angles and they are equal. We have other angles having the same situation here. For example, angle 2 is equal to angle 6. Angle 3 is equal to angle 7. Angle 4 is equal to angle 8. All of these are because they are a corresponding angles. Another relationship we can see between these angles: angle 3 is equal to angle 5 and angle 4 is equal to angle 6 because these two angles are called an alternate angles. But these angles are alternate from inside the intersection, so we can call them interior alternate and there is an exterior alternate between the angles 1 and 7, angle 2 and angle 8. So these are an interior alternate angles and these are an exterior alternate angles, and the relationship is equality between them. If we come to the definition of the polygons, so any geometric shape which is closed and composed from sides, we call it a polygon, and it may has 3 sides like this one, so we call it a triangle, or 4 sides like this one, and we can call it a quadrilateral, or 5 sides where we can call it a pentagon, or 6 sides where we can call it a hexagon, and if it has 7 sides, then we call it a heptagon. 8 sides, we call it an octagon. By this we reached the end of our lesson. We just wanted here to review some definitions and relationships for angles, lines, and geometric figures.